Hello everyone, welcome to this video lecture on Project Network Models Part 1. In this video lecture, we are going to discuss about network diagram construction and critical path method procedure. Any project involves planning, scheduling and controlling a number of interrelated activities with use of limited resources like men, machine, material, money, energy and time. And the projects may be extremely large and complex, such as construction of a house, a highway, a shopping complex, etc. And it even may be a research and development project or introduction of new products. For these complex projects and the research and development projects, it is required that the manager must have a dynamic planning and scheduling system to produce the best possible results and also to react immediately to the changing conditions and environment and make necessary changes in the plan and schedule. For helping the manager, there is a convenient analytical and visual technique which is actually called as PERT and CPM, which is proven extremely valuable in assisting the managers in managing the projects. Here, PERT stands for Project Evaluation and Review Technique. Developed during 1950s, the technique was developed and used in conjunction with the planning and designing of a Polaris missile project. CPM stands for Critical Path Method, which was developed by DuPont Company and applied first to the construction projects in the chemical industry. Though both these PERT and CPM techniques have similarities in terms of concepts, the basic difference is CPM has single time estimate, which is actually a deterministic one, and PERT has three time estimates like optimistic time, pessimistic time and most likely time for each and every activity, and which uses the probability theory to find the chances of reaching the scheduled time. Basically, the CPM, that is critical path method, is used for finding and scheduling planning for the repetitive projects, which is very much known. And this PERT technique, that is program evaluation and review technique, is used for future and R&D projects. And these are some of the applications of these project network models, that is PERT and CPM, which is used for planning, scheduling, monitoring and control of large and complex projects. Construction of factories, highways, buildings, bridges, cinema halls, etc. Helpful to Army for its missile development, assembly line scheduling, installing of computers and high-tech machineries, to make marketing strategies. These are all some of the applications of this PERT and CPM techniques. And if it is a project management, it generally consists of three important phases. One is actually called as planning phase, another one is scheduling, and finally we have controlling phase. Planning involves setting the objective of the project, identifying various activities to be performed, and determining the requirements of resources such as men, material, machine, time, energy, everything. And here the cost and time of all the activities are estimated and a network diagram is developed showing sequential interrelationship between various activities during the planning stage. So in the CPM, the first most important one is we have to construct the network diagram, and the second one is we have to develop the sequential interrelationship between various activities. This will be done during the planning phase. After doing these two things, then we have to move on to the scheduling. Based on the time estimates, the start and finish time for each and every activity are worked out by applying forward and backward pass techniques in this phase, that is in the scheduling phase. After doing this, we'll be estimating T and TL value in the scheduling phase first. Then the critical path is identified along with the slag and float for the non-critical paths. So after doing this, in the controlling phase, which refers to analyzing and evaluating the actual progress against the plan. If required, reallocation of resources, crashing and review of projects with periodical reports are carried out in the controlling phase. So in the planning phase, after knowing the sequential interrelationship between various activities, the network diagram is constructed, and in the scheduling phase, the start and finishing time for each and every activity is worked out by using forward and backward pass technique. Then the critical path is identified. Then the slag and float for the non-critical paths are evaluated. In the controlling phase, if required, reallocation of resources, crashing and review of the project will be done. This is actually called as network crashing technique. In short, this is the methodology involved. First, we have to describe the project. Then, we have to construct the network diagram by using the relationship between all the activities. Then, after doing this, we have to estimate the time of completion by using two different methods. Depends upon the application, whether it is a repetitive project or a R&D project or future project. If it is a repetitive project, we have to use critical path method, which involves deterministic estimates to find out the estimated time of completion. If it is a future project or a R&D project, we have to use PERT, that is Program Evaluation and Review Technique, which is a probabilistic estimate to find out the time of completion. Then after doing this, if required, we'll be going for project network crashing, which is in the phase of monitoring the project progress. Next, we'll discuss about some key terminologies used in PERT and CPM. First and foremost is activity. All projects may be viewed as combination of activities. It is the smallest unit of work which is consuming both time and resources that project manager should schedule and control. Normally, the activity will be represented by an arrow in a network diagram like this. This arrowhead represents the sequence of activities, whether it is going from left to right or right to left. It will indicate the sequence. And there are four different types of activities. One is actually called as predecessor activity. That is the activity that must be completed immediately prior to the start of another activity, which is actually called as predecessor activity. Next one is successor activity. Activities that cannot be started until one or more other activities are completed but immediately succeed them are called successor activities. Next is concurrent activities. These activities that can be accomplished together are known as concurrent activities. And the fourth one is dummy activity. This activity will not consume any resource but merely depicts the dependence of one activity on another is actually called as dummy activity. It is actually introduced in a network when two or more parallel activities have same start and finish nodes like this. Here you can see this. This is actually one of the starting node and this is ending node. Two activities are starting from the same node and ending in the same node. So if this is the case, this should be avoided. For avoiding this, we will be using a dummy activity like this. So here you can see this activity B and C are starting from the same node, which is actually node number 2, and which will end in the same node, which is 4, right? So we should not use it like this. For this, what we can do is we can directly connect one of the activity. Here B activity is directly connected. Another activity is connected in a separate node like node number 3. Then we can use a dummy activity to have the dependency relationship between these two, right? This is the usage of dummy activity. Here we have 4 different activities. In this diagram, you can see this. A is the predecessor activity for B, right? So if you want to start the activity B, A should be completed before that. So the predecessor activity is A for B, right? The same way, B is the successor activity for A. And concurrent activities, here B and C are the concurrent activities. It is accomplished together. The starting point is the same, that is node number 2. So these two activities are called as concurrent activity. This is actually the dummy activity, right? Next important component is event. Here the beginning and end of an activity are called as events. The node points are called as events. Events are represented by numbered circles called nodes. So this is the starting event or node. I is the starting node and this is actually an activity, and this is J is the ending event or node. So if there is an activity, we have two different events. One is starting event, another one is ending event. And there are three different types of events. One is merge event, like this. This is the event. If there are one or more activities will come and merge in a single event, that is actually called as merge event. Burst event. If there are two or more activities starting from the same node, it is actually called as burst event. And third one is merge and burst event. And here two activities are merged in a same event, and from the same event two activities are burst out. So this is actually called as merge and burst event. So there are two important components for PERT and CPM. One is activities, another one is event. If you just consider activities, there are four different types of activities: predecessor activity, successor activity, concurrent activity, and dummy activity. And there is an event. So if there is an activity, there will be one starting event and one ending event. That events are actually called as nodes. And we have three different types of events like this. And next comes path. Here you can see there is a network diagram. And you can identify predecessor, successor, concurrent and dummy activities here. For the activity lay foundation, predecessor activity is design house and obtaining financing. This is actually the predecessor activity for lay foundation, right? For build house activity, order material is the predecessor activity. The same way, for order materials activity, build house is the successor activity. And while coming to the concurrent activity, build house and select paint, these are all the concurrent activity which is starting from the same node. And this is your dummy activity. Here you can see the usage of dummy activity. Here, after having the design of the house and obtaining financial sanction, something like that, we have two different processes or activities that can be start from the node number 2. That is, we can just lay foundation. At the same time, we can order materials, right? After doing these two activities, that is laying foundation and ordering materials only, we can start our housing construction, right? So for this, we can use a dummy activity. Okay, right. Next comes the path. Path is actually an unbroken chain of activities connecting the initial event to some other event, whatever may be the event. Let me have the other event as the last event. Here the path is, we have so many different paths to reach starting event to end event. One of the path is 1, 2, 4, 6, 7. This is one of the path, right? Which is a chain of activities connecting initial event to some other event. Just I am having it as end event. Another path is 1, 2, 3, 4, 6, 7. One more path 1, 2, 3, 4, 5, 6, 7. One more path 1, 2, 4, 5, 6, 7. So these are all actually called as path, which is actually unbroken chain of activities connecting the initial event to some other event. Next is network. A network is the graphical representation of logically and sequentially connected arrows and nodes representing activities and event of a project. It's a diagram depicting precedence relationship between different activities. This is actually one of the network diagram. Network diagram for the construction of a work. And before drawing the network diagram, we should know what are the common errors in drawing networks. One of the errors is dangling. Another one is looping or cycling. And third one is redundancy error. So this is actually called as dangling error. If there is a network diagram, there should be only one initial event and only one terminal or end event. There should not be any loose ends like this. So here the starting event is 4 and ending event is 12. And here you can see there is one loose end and here there is another loose end. So if there is a network diagram, there should not be any loose ends like this. If there is any loose ends like this, that should be connected to the end event with a dummy activity like this. So we can just connect 7 to 12 by using a dummy activity, which is a dotted line. The same way here there is another loose end. We have to connect 10 to 12 by using a dotted line, which is a dummy activity. And another one we should consider is there should not be any cross line in between the network diagram. So if we directly connect 10 to 12 like this, there is a crossing of lines. For that, what we can do is we can just extend this 10 up to this and we can connect the 10 to 12 like this, right? So dangling error is there should not be no loose ends. So that is actually, if there is a loose end, that is actually called as dangling error. It should be avoided. And the next one is looping or cycling. So this is actually called as looping or cycling, right? It is a drawing an endless loop in a network is actually called as erroring or error of looping. Here you can see this, starting with 20, it is going to 22, 23, 21, again 20. So it is an endless loop. So it is very meaningless. So actually it should be like this, 20 to 22, 20 to 21. The arrowhead should be like this. And here also this arrowhead should be like this. So this error of looping should be avoided. That is the second error. Third error is like this. You should not use or provide any unnecessary dummy activity in a network like this. So here this event is connected to this event by using an activity. Another activity is used for connecting these two nodes. But you should not use a dummy activity like this unnecessarily to connect these two nodes. That is actually called as redundancy error. So these are all the common errors in drawing the networks which should be avoided. Next comes the guidelines for network diagram construction. So if it is a PERT network or a CPM network, the first thing is we have to construct the network diagram. Then we have to calculate TL and TE values. Then we have to calculate or we have to determine the critical path and so on. This is the usual procedure. So the first procedure is we have to construct the network diagram by having the interrelationship between the activities. So while drawing the network diagram, a complete network diagram should have only one start point and one finish point. And the flow of diagram should be from left to right. Arrow should not be crossed unless it is completely unavoidable. Arrow should be kept straight and not curved or bent. Angle between arrows should be as large as possible. Each activity must have a tail or head event. Tail event means starting event. Head event means ending event, right? No two or more activities have same tail and head events. If there is such a case, we have to use the dummy activity to have the proper relationship. And once the diagram is complete, the nodes should be numbered from left to right. And it should then be possible to address each activity uniquely by its tail and head event. Tail event means starting event, head event means ending event. And there are some situations in network diagram. So this is one of the situation. That is, the activity A must be finished before either B or C can start. If there is a relationship like this, we have to depict it like this. Next is, both the activities A and B should be completed before the activity C can start. Now here, both the activities A and B must be completed before either C or D can start. Here there is a confusion. Both A and B should be completed before either of C or D can start. Next is here, A must be completed before B can start. At the same time, here A and C should be completed before D can start. If this is the case, we have to use a dummy activity like this. If you are using a common event here, right, like this, A or like this, here A, C, B, D, if you just, instead of doing this, if you just having it as A, C, B, D like this, the problem will be after completing A and C only, B also can start. So that leads to wrong relationship. So we have to use a dummy activity like this if there is a relationship like this. That is, A must be completed before B can start. So it is a separate one. Here D should be started only when A and C can complete. Right? So for this we can use a dummy activity like this. So these are all the different situations in network diagram construction. Next comes the network diagram construction. So this is a given problem. Activities are given and the predecessor activities also given. We have A, B, C, D, E, F and G. So 7 activities, and here the predecessor activities are given. For the activity A, there is no predecessor activity. For the activity B also, there is no predecessor activity. That means A and B are the starting activities. Alright? And for the activity C, predecessor activity is A, and so on. Alright? We will see how we can construct the network diagram one by one. So we know that there is no predecessor activity for A and B. So A and B activities are the starting activities. So we can start from here. Single start node, and A and B are the starting activities. So it will be a concurrent activities like this. Activity A, from the start, there should be only one starting event and one end event. So from the starting event, I'll just have the activity A like this, and this is the activity B, right? So these are all the concurrent activities because there is no predecessor activity for A and B. So these are all the starting activities. After doing this, we have to go for next one. For activity C, A is the predecessor activity. So if we want to start the activity C, A should be completed, right? After completing A only, C can start. So we have to have a event. If there is an activity, there should be one starting event and one ending event for that particular activity. So this is actually ending event for activity A. From this, C can start like this, right? Now we can see this. After completing A, C can start, right? The same way, D, for activity D also, A is a predecessor activity. So C and D are concurrent activities starting from this node. So this is our activity D. And next is activity E For activity E, producer activity is B. So from the end event of B, E can start. Like this. Alright. Next comes for activity is F, producer activity is C. So here the activity C, from the end event of C, F can start like this, right? Next, for activity G, D and E are the producer activities. So after completing D and E only, G can start. So we should have a common node for the common end node for D and E, like this, like this. So from this common event, G can start like this, right? So the producer relationship are over. Now there should be one starting event and one ending event. So we have two loose ends like this, and there should be some ending event. So we are ending with an end event like this. So this is actually called as network diagram construction. Next, after constructing the network diagram, we have to number the events left to right. So starting from 1, next we can look for this one, A activity, 2, then B, 3, C, 4, then 5 and 6. So this is how we have to number the activities. So this is how we have to construct the network diagram by using the relationship between the activities. Then we have to number the events. We will have one more network diagram. So here 1, 2, 3, 6 activities are given A to F, and the producer activity for each and every activity is specified here. And here it is specified as there is no producer activity for activity A. So activity A is the starting activity. So we have to start from a starting event like this, and there is only one activity, activity A. Alright, and the next one is B and C. For the activity B and C, A is the producer activity. So B and C will be the concurrent activities from the end node of A. So this is the end node or end event of A, and from this B and C can start. This is B and this is C. And after doing this, for the activity for the activity E, producer activity is C. So from after completing C, the activity E can start. Before this, here there is another activity, that is activity D. For the activity D, producer activity is B, right? So after completing B only, D can start. So here it is D, and for this, after completing C, E can start like this. And for the activity F, the producer activities are D and E. So for the end event of D and E, we can have a common event like this, and from this event F can start, and there should be one ending event. So this is the ending event. So this is how we have to construct the network diagram. And next one is we have to number the entire network diagram starting from left to right. So this is 1, 2, 3, 4, 5 and 6. So this is how we have to construct the network diagram, right? So this phase is over. Next comes critical path analysis. So if you want to construct the network diagram, that is if you want to find out the critical path, first we should know what is a critical path and its impacts. Then we have to calculate TE and TL values. Then comes critical path. And the critical path of any network is the longest path through the entire network. We have seen so many paths for starting from starting event to end event. So here we have to find out the longest event through the entire network, that is actually called as critical path. And the critical path is actually denoted by a darker line or with double lines. And since all the activities must be completed to complete the entire project, the length of the critical path is also the shortest time allowable for completion of the project. So length of the critical path is actually the longest path. That path will be the shortest time allowable for completion of the project. Thus, if the project is to be completed in that shortest time, all activities on the critical path must be started as soon as possible. There should not be any delay in the critical activities. These activities on the critical path is actually called as critical activities. So if the project has to be completed ahead of the schedule, that is before the schedule, then the time required for at least one of the critical activity must be reduced. That is actually called as crashing of the network. That can be accomplished by having some more resources or some more money. Further, any delay in completing all the critical activities will increase the project duration. If there is any delay in completing any one of the critical activity also, that will increase the project duration. So critical activities are that much important. The activity which does not lie on the critical path is actually called as non-critical activity, and these non-critical activities may have some slack time. The slack is the amount of time by which the start of the particular activity may be delayed without affecting the overall completion time of the project. But the critical activity means it doesn't have any slack. To reduce the overall project time, it would require more resources at extra cost to reduce the time taken by the critical activities to complete. That is actually called as crashing of the network. We'll see that in the forthcoming videos. Next comes the usefulness of this PERT and CPM network. It have been useful in planning costs, scheduling manpower and machine time. And this CPM and PERT techniques can answer the following important questions. That is, what will be the project duration? What are the critical activities which could delay the entire project if they were not completed on time? What is the current status of the project? That is the project on schedule, behind schedule or ahead of schedule? If the project has to be finished earlier than planned, what is the best way to do this with the least cost? These are all the answers what we can expect from this CPM and PERT technique. And there are some differences between PERT and CPM. PERT is actually a probability model with uncertainty in activity duration. The duration of each activity is computed from multiple time estimates, normally 3 estimates: optimistic time, most likely time and pessimistic time, with a view to take into account time uncertainties. And whereas CPM is a deterministic model with well-known activity times based upon the past experience. And PERT is applied widely for planning and scheduling research projects and new product development. And CPM is used for construction project and business problems, which is very repetitive in nature. PERT analysis does not usually considers cost. It only considers the time, whereas CPM deals with cost of the project schedules and minimization of it by doing crashing of the network. These are all the major difference between PERT and CPM. Okay, next comes scheduling of activities. After doing the network diagram construction phase, we have to move on to the scheduling of activities. Before the critical path in a network is determined, it is necessary to find the earliest and the latest time of each event to know the earliest expected time, that is TE, at which the activities originating from the event can be started and to know the latest allowable time, that is TL, at which activities terminating at the event can be completed, right? And this TE value, that is earliest time, can be calculated by using forward pass computations. The steps are, first we have to begin from the start event and move towards the end event. First we have to put T is equal to 0 for the start event. Then we have to move on to the next event, that is node number 2. If there is an incoming activity for the event 2, we have to add TE of the previous event and activity time of this particular activity. The arrived value is TE for that event. If there are more than one incoming activities, we have to calculate TE for all incoming activities and we have to take the maximum value among that. This value will be the TE for the event number 2. And we have to repeat the same procedure from step 3 till the end event. This is about forward pass calculation. Next is backward pass calculation. This is for calculating the latest time, TL, latest allowable time for each and every event. We have to begin from the end event here and move towards the start event, assuming that the direction of arrows are reversed. We are just assuming it, we are not doing it. We are just assuming it as a direction of arrows are reversed and we are going to begin from the end event and moving towards the start event. Here the latest time TL for the last event will be equal to TE value of the last event. So TL will be equal to TE for the last event. We are starting from that TL value. Then we have to move on to the next event in the reverse way. If there is an incoming activity, we have to subtract the activity duration time with the value of TL of the previous event. That arrived value will be TL for that event. And if there are more than one incoming activities, we have to take the minimum TL value. While doing forward pass computation, we were taking maximum among all the TE values. While doing reverse calculation, we will be taking minimum among TL values. This is a major difference. And we have to repeat the same procedure until all the events are completed till start event. Alright. As discussed earlier, the non-critical activities have some slag or float. We have to determine the slag and floats for each and every activities. The float of an activity is the amount of time available by which it is possible to delay its completion time without extending the overall project completion time. Actually, there are three types of floats. Total float, which is the spare time available when all preceding activities occur at the earliest possible times and all succeeding activities occur at latest possible times. Right? This can be calculated by using a formula. Total float is equal to LS minus ES or LF minus EF. Latest time minus earliest time for that particular event or latest finish minus earliest finish for that particular event. Next is free float, the time by which the completion of an activity can be delayed from its earliest finish time without affecting the earliest start time of the succeeding activity is called as free float, and this can be calculated by using the formula free float is equal to total float minus head event slag. Head event slag means head event means end event of the particular activity. The slag means difference between TE and TL value of the end event, that is head event slag. Next is independent float. This is the amount of time by which the start of an activity can be delayed without affecting the earliest start time of any successor activity, assuming that preceding activity has finished at its latest finish time, right? And if there is any negative value for this independent float, we have to consider it as 0. And the formula for calculating the independent float is, it is equal to free float minus tail event slag. Tail event means the starting event, slag means difference between TE and TL value, right? Okay, this is how we have to calculate floats and slags. So we have discussed about how to construct the network diagram and what are all the steps involved in critical path method calculation. With this, next is critical path. After determining the earliest and latest scheduled times for various activities, the minimum time required to complete the project is calculated. In a network, among various paths, the longest path which determines the total time duration of the project is actually called as critical path. And the following condition must be satisfied in locating the critical path of a network. That is, the activity is said to be critical only if both the conditions are satisfied. One is TL minus TE is equal to 0. That is, TL value should be equal to TE value for that particular activity. Another condition is TL of end event minus the activity time minus TE of the end event should be equal to 0. If both the conditions are satisfied, then only the particular activity is said to be critical. And if you are just connecting all the critical activities together, that leads to critical path, which is actually the longest path, which determines the total time duration of the project, right? So this is how we have to calculate the critical path, total float, free float and independent float for all the activities. Thank you all for the patience hearing. In the next video lecture, we are going to discuss about how to solve a project and how to determine a critical path and how to calculate floats, all the floats for all the activities by using critical path method. Thank you.